Hello guys, how are you today? So today I'll be explaining the chemistry AMS quiz of term 2 week 7. So let's start. Which of the following is the electron configuration of the sodium atom, Na11? Now you have to pay attention if they tell you atom or ion. There is a great difference. The atom does not have a noble gas configuration. So when they say the sodium atom, they are meaning or referring to Na11 itself. So to do the electron configuration, we are going to put the blocks, okay? And we are going to say that here fits 2, here fits 8, here fits 8, here fits 2. So if we are dealing with 11, it's going to be 2, 8, 2 plus 8 is 10, and we will be left with 1 over here. So this is the electron configuration of the sodium atom. However, if they asked about the sodium ion, we would be dealing with Na+, so 11 Na+. Okay, so it means it has reached the noble gas configuration. So that means it should have 8 valence electrons. So when we are dealing with it, here 2, 8, 8, 2, it must have exactly 8 valence electrons. So originally the atom is 281. It is easier to lose 1 electron than to gain 7. So then the electron configuration of the sodium ion is 2, 8. So we move on to the next question. Which of the following arises from equal sharing of 2 electrons? It is very simply covalent bonding. Metallic bonding is between 2 metals. Ionic bonding is when one is gaining an electron and the other is losing an electron. Covalent is when you are sharing 2 electrons, 2 or more electrons, okay? And then an electron bond is just like the bond in between the electrons. So it has nothing to do with sharing, giving, taking, whatever. So what you should know is that sharing electrons is covalent bond. Giving and taking electrons is ionic bond. Between 2 metals, it's a metallic bond, and electron bond is just the bond in between the electrons. So we move on to question number 3. Now for question number 3, they told us which of the following are correct electron dot diagram of magnesium ion. They said what? Ion, that means it has reached the noble gas configuration, meaning when we are gonna be dealing with the Mg electron dot diagram, okay, we can do it in 2 ways. The first way is to put the exact number of valence electrons, so we are gonna be forgetting about all the other shells. So Mg has an atomic number of 12. So if we did its electron configuration, it's gonna be 8, sorry, not 8, it's gonna be 2, 8, 2. Okay, so what's gonna happen for it to reach the noble gas configuration? It's gonna lose 2 electrons, so it's gonna be 2 plus. So if you were to denote it in the beginning, it was gonna be 1, 2, then 1, 2, actually let's do it like this, 1, 2, 3, 4, 5, 6, 7, 8, then another shell that had 2. But because it wants to reach the noble gas configuration, which has 8 valence electrons, it lost this shell with the 2 electrons, okay? So then it was just like this. That means you can denote it like this if you are doing it with the electron clouds. Or another way to denote it is like this. You do 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then you enclose it because it has a charge, so it's charged 2 plus. Or you could just write Mg and then put it 2 plus. You only do this for the cation. For the anion, you have only one way, which is to do it like this. Whereas for the cation, you have 2 ways. You can do it like this or like this. Okay, so for here, the answers are this one and this one. Moving on to question number 4. They said select the correct dot and cross diagram for the given compound. So let me open the periodic table. Okay, so this is the periodic table I'm going to be using because it's similar to the ones they give us in the exam. So they tell us select the correct dot and cross diagram for the given compounds. Starting with HF. Okay, how do we do the dot and cross diagram? We're going to first of all go to the chemistry periodic table, and we're going to have H. Hydrogen is 1, so it has an atomic number of 1. And then F, which has an atomic number of 19. Okay, so we're going to go back and we're going to... Oops, sorry, I opened my economics. So this is the chemistry periodic table I'm going to use because it's similar to the one they give us in the exam. Okay, so we're going to go back. They told us select the dot and cross diagram. We're going to start with HF, okay? So we're going to come over here, and we're going to see that hydrogen has an atomic number of 1, whereas fluorine has an atomic number of 9. Okay, so we're going to keep this in mind, and we go back to the quiz. HF, we know H is 1 and F is 9. For H, doing its electronic configuration, we are going to get 1. So it's going to have H and it is going to have 1 free electron. F, on the other hand, if you do its electronic configuration, it's going to be 2, 7. So that means there are going to be 7 valence electrons around F. So F is going to have 1, 2, 3. I missed one. 1, 2, 3, 4. I'm going to use actually a different annotation. So I'll use a different color to make it easier. 1, 2, 3, 4, 5. So 6 and 7. So what's going to happen is that H has 1 free electron. F has 1 free electron. They are going to come together to make what? To make a lone pair of electrons. So it will become stable. So in other terms, it makes like a smiley face. So it's going to be H. Okay, we're going to use the blue again. So blue. And then red, F, 1, 2, 3, 4, 5, 6. So like this one is the correct. The first one is correct. Okay, so we move on to the second one. We have H. We actually have H, S, H. It's in this format. Okay, and if we go back to the periodic table, H has atomic number of 1. S, let us find S, has an atomic number of 16. So we're going to go back, okay. We remember H, S, H, 1, 16, 1. Okay, here electronic configuration is 1. Here it is 2, 8, 6. And here it's gonna be 1. So again, H is gonna have 1 free electron. S, on the other hand, has 6 free or valence electrons. So I'm gonna choose green. So it's gonna be 1, 2, 3, 4, 5, and 6. You will now see why I did it like this. Then we have the other H, which will have another free valence electron. So if we are going to put them all together, it's going to be H, S, H. Okay, so it's going to be H and S will have a lone pair like this. Okay, then the other H and S will have another lone pair like this. So taking this one, it is similar to this, so it is then correct. Okay, I'm gonna do this one, NaI, but I will do it in the way that they presented it. So Na, you will go to the periodic table, you will get that it has an atomic number of 11, and I has an atomic number of, actually let me go back to the periodic table. I has an atomic number of 53. Now for I, we cannot be using, sorry, that's my economics, we cannot be using the electronic configuration, which is the 2882. So what we are going to be doing for I is the SPDF, okay? How do we do the SPDF? We're going to do first of all, it starts with S, then SP, then SPD, then SPDF. Okay, then we number them 1, 2, 3, 4. This we start by 2, so 2, 3, 4. We start by 3, 3, 4, and then 4. Then we know that S can hold 2 electrons, P can hold 6 electrons, and D can hold 10 electrons, and F can hold 14 electrons. So we're dealing with I, which has an atomic number of 53. So it's going to be 1s2. So we got rid of 2. So take your calculators. It's going to be then 53 minus 2, which is 51. So we're left with 51. So then it goes 2s2, again, minus 2. We are left with 49. Now 2p6 minus 6 electrons, we are left with 43. Okay, then 3s2 minus 2 electrons, we are left with 41. So, okay, then we have 3p6 minus 6 electrons, we are left with 35. Then 3d10 minus 10 electrons, we are left with 25. 4s2 minus 2 electrons, we are left with 23. Then 4p6 minus 6, we are left with 17. Then 4d10 minus 10, we are left with 7. And then finally 4f, it can hold 14 electrons, so we will just put 7. Okay, so I is gonna lose, this is a really long process, but this is the only way to do it. So I is gonna have 7 valence electrons, whereas Na, if you do the electronic configuration, it's gonna be 2, 8, 1, it's gonna have 1 free electron. So let us draw it. Na has 1 free electron, which is over here, let us say, and I has 7, so 1, 2, 3, 4, 5, 6, and 7. So you can put them together, okay, and you can write it in this format. So Na will lose an electron, so it's gonna be plus, okay. You cannot write it like in the format we did for HF and HSH, because this is what? This is an ionic bonding and not a metallic bonding, okay? Sorry, not a covalent bonding. Covalent bonding is between two nonmetals, whereas ionic bonding is between a metal and nonmetal. So Na plus, okay? Then we put this I. You can put the this if you want. 2 minus. Now let us see if this makes sense, by the way. Based on what we got, we know that I has how many free electrons? It has 7. 1, 2, 3, 4, 5, 6, 7. Okay? And the Na has 1 free electron, so it will come together. If Na lost 1, how can the I gain 2? This doesn't make sense. So definitely, this is a wrong annotation or a wrong way of putting it. So this one, I'll let you guys do it by yourself, but I'll tell you it's correct. This one, I will do it for you because it's a bit complicated. So we're going to do Mg, F here, and F here. So looking at the periodic table, Mg, where is Mg? 1 second, let me find it. Has an atomic number of 12. F has an atomic number of 9 and 9. So if we do the electronic configuration, it is going to be 2, 7. This one is going to be 2, 8, 2. And this one is also going to be 2, 7. So this has 7 valence electrons, this has 2 valence, and this has 7. But pay attention, it is what? It is ionic bonding. So we will not put it in the format we did for this and this and this. No, we are going to put it in a format like this. Okay, so we will do it in this format. Actually, let me put it here. We are having Mg. Mg has 2 valence electrons, but it's going to lose them and become Mg2+. This you can figure it out by memorizing the ions and whatever. Now, F, however, we have F here and F here. Okay, we're gonna draw the valence electrons. It has 7 valence electrons. So 1, 2, 3, 4, 5, 6, and 7. Then 1, 2, 3, 4, 5, 6, and 7. Now, the Mg is gonna give 1 to this and 1 to this. And like this, they would have what? They would have had the noble gas configuration. Now, one thing I would like to mention is that we know ionic bonds, they do not share the electrons. So that's why we represent it like this and not like how we would represent this. So this is definitely correct. And this is pretty much it for question number 4. We move on to question number 5. Here you have to remember a single covalent bond formed between two atoms where only one of them shares both electrons, for example. So let's take as an example H3O+. Okay, we have H. First of all, let us do HOHH. Okay, H has 1 free valence electron, whereas O, if you do its configuration, O has an atomic number of 8, so it's gonna be 2, 6. It has 1, 2, 3, 4, 5, and 6. So look, as you notice what's happening. This is normal. This is normal, but over here, look what's happening. Only the H is sharing what? It is sharing both electrons of the bond with O. So we call this what? We call this a dative, or there is another name for it, I forgot, or a coordinate bond, okay? So we move on to question number 6. The atomic number of phosphorus is 15. Select the electron dot diagram of phosphide ion. Again, phosphide ion, we are talking, it has the noble gas configuration. Okay, so it has an atomic number of 15. Let us do the electron configuration. So it's gonna be 2, 8, and 5. So it has 5 valence electrons. Now we're talking about an ion, okay? So what's gonna happen is we're gonna have P, and it's gonna have 1, 2, 3, 4, and 5. But then for it to obtain the electron configuration, it's gonna gain 3 ions, so it becomes 3 minus, and it has 1, 2, 3. So very simply, it's gonna be this one over here. I'll tell you why now. Because look how this is placed. You cannot place it like this. You should place it like this. So one is from P, another is not from P. One is from P, another is not from P. One is from P, another is not from P. Okay? Whereas if you place it like this, this is totally incorrect. Okay? So please pay attention to which one you are choosing. Moving on to question number 7. They said select the correct electron dot diagram of a neutral atom. A neutral atom means it did not receive or lose any electrons. So we're gonna keep in mind these over here, okay? So they told us oxygen has an atomic number of 8. That means if you do the electron configuration, 2, 6, it's supposed to have 6 valence electrons if it is neutral, meaning it has no charge. So 1, 2, 3, 4, 5, 6. And they are placed in the correct order, so we are gonna choose it. Boron has 5, so it is gonna be 2, 3, so it's gonna have 1, 2, 3. Again, this is correct, it's neutral. Nitrogen has 7, so 7 is 2, 5, so it's gonna have 1, 2, 3, 4, and 5. Now, why is this incorrect? It is because of the placement, so you have to place it correctly. It should be in this form, how I drew it. So N, 1, 2, 3, 4, 5. 2 on top, and then 1, 2, 3 loose. So this is incorrect, we are not choosing it. And Se has 34, so we cannot apply this one. We're just gonna apply the SPDF. So S, SP, SPD, SPDF. Okay? So 1, 2, 3, 4, 2, 3, 4, 3, 4, 4. 2, 2, 2, 2, 6, 6, 6. Was it 10, 10, and 10, and then 14. Okay, so let us do it. We start with 1s2, then you take your calculators, okay? So we know it has 32, so 34. 34 minus 2 is 32. Then 2s2, again, answer minus 2, you get 30. Then 2p6 minus 6, you get 24. Then 3s2 minus 2, you get 22. Then 3p6 minus 6, you get 16. And then after 3p6, we have 3d10. So minus 10, you have 6. Then 4s2 minus 2, you have 4. And finally, you're going to put it 4p, but to the power of 4. So that means it has 4 valence electrons. So if you check over here, it definitely does not have 4. It's supposed to be 1, 2, 3, 4. This does not have 4 valence electrons, so we are not going to choose it. We move on to question number 8. Here you have to select the molecules that have coordinate covalent bonding. So what you're going to do is you're going to draw them. So you have C, O, O, O. Okay? And then O, H, H, H. This is for the H3O. Then here it is B, F, 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 and F. Then you have to draw. Okay, O, we will do its electron configuration. 2, 6. That means it has 6 valence electrons. 1, 2, 3, 4. Then I prefer to do 1 here. And 1 here. So it's 1, 2, 3, 4, 5, 6. Same for here. 1, 2, 3, 4, 5, and 6. Then as well, 1, 2, 3, 4, 5, and 6. Okay, then C has carbon has 6, so it's gonna be 6, 4, and it has 4 valence electrons, so it's gonna be 1, 2, 3, 4. Now here it's a bit complicated because as you can see, you have one is free, another is free, then you have this over here is free, and this over here is free. So it's definitely not applying coordinate covalent bonding. So this is incorrect. If we move on to the OH H3O, we're gonna have 1, 1, 1, and then this has an atomic number of 6, so 1, 2, 3, 4, 5, and 6. So as you see, this has one bond that is coordinate covalent, and these are regular bonds, so definitely this applies the rule. Now finally, if we move on to BF 4-, it's gonna be F has F is 9, so it's gonna be 2, 7. It has 7 valence electrons, so 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, and 7. Okay, and boron B has an atomic number of 5, so it's gonna be 2, 3, its electron configuration. So it's gonna have 1, 2, and 3. So we have one electron which is free, which makes it the BF-, okay? But otherwise, it does apply to the coordinate covalent bonding. Now, this is something we're gonna learn later on. It is apparently based on the octet of the BF4-, but for now, memorize that BF4- has coordinate covalent bonding. So these two are the answers. Moving on to question number 9. This is very simple. Magnesium chloride is MgCl2. You should know it by now. Potassium sulfide is K2S. I think I wrote it wrong. K2, then S. Aluminium oxide is Al. Oops. 2O3. Calcium nitride is Ca3N2. Now, by the way, if you do not know how to get them, go to the chemistry periodic table and memorize this. This has 1 positive, 2 positive, 3 positive, 4 positive, or it could be 4-. Okay. This has then 3-, 2-, 1-, and 0. Okay, so when you are trying to find out their electrons, this is gonna be Li plus, Na plus, K plus, and etc. This, for example, is gonna be B3 plus, Al3 plus, Ga3 plus. Okay, this is gonna be F-, Cl-, I-, like just write this, and from this you will take the charge or the resultant charge. So this one, the bromide ion, it is Br-. An oxide ion is O2-, 2-. A calcium ion is Ca2 plus. Okay, and a boron ion is B3 plus. Okay, we move on to question number 10. We need to write the electron configurations for the following ions, so pay attention, they are ions and not atoms. So you can do it in 2 ways. You can do it like this, or you can do it in the SPDF. So I'm gonna do it in both ways for the first one. Okay, 1, 2, 3, 4, 2, 3, 4, 3, 4, and 4. Okay, so for the first one, if we did it in the electron configuration, it's gonna be 2, 8, 3 if we are talking about the atom, but since we're talking about the ion, it lost 3 electrons, so this goes away, so its electronic configuration is 2, 8. If you want to do it with the SPDF, you're gonna have 2, 2, 6, so this in total is already 10. Okay, and this over here is then gonna hold 2 and 1. So if we are talking about the aluminium atom, it's 1s2, 2s2, 2p6, 3s2, 3p1. So 2, let me just check 1 second. 2 plus 2 plus 6 plus 2 plus 1, you're gonna get 13. But it lost 3 electrons, so it's losing this one and this one. So its electron configuration is gonna be 1s2, 2s2, 2p6. So you can write it in either way. I'm just gonna write it 2, 8. For the second one, I'll let you guys do it because it's really simple. I'll just give you the answers in SPDF and electron. So in electron configuration, it's gonna be 2, 8. And if we are talking about the SPDF, it's gonna be 1s2, 2s2, 3p6. That's pretty much it. Moving on to question number 11. Okay, this question is very, very nice. Pay attention. Here it is what? It is a compound in the form of a compound. All right, but when you move on to the question, they ask for the configuration of the element. not in the compound. So when they're asking for the configuration of the element X, okay, first of all, we know that Mg is going to be Mg2 plus, and X is probably going to be 2X minus. All right, so if you split them into their atoms, Mg2 plus and X minus. Okay, you guys by now should know how to split into the atoms. Now, X minus means it has gained an electron, so let us say its configuration is, for example, it can be 2882, or it can be 288, or it can be 28. Sorry, this one is not. So it can be either any of these, okay? Now, if it gained an electron to gain the configuration of this, that means originally it had -1 from this. So it's going to be either 27 or 287. Checking our possible answers, we have 287 as an option, we take it. We move on to question number 12. They said X has a high tendency to form negative ions, so X minus, okay? Y has tendency to form 2 plus, so X minus, Y2 plus. Okay, so they need what? The possible electron configuration for the elements X and Y. So X had to gain, so it can be either 28 or 288 as long as it ends with 8. Here it's the same thing. So here it had to gain an electron, so we're going to subtract 1 from the last digit. It could be 27 or 287. Here it had to gain 2 electrons. Here it had to lose 2 electrons in order for it to be have the configuration of a noble gas. So it could be 282 or 2882. Could be either of these two. So if we open our answers and check, here we have 287 and 2882. Okay, so we move on to question number 13. Here, this is pretty simple. The gases reacting in hydrogen fuel cell are H2 and O2, and it will produce only pure water. Okay, moving on to question number 14. Here, you should know that the only pollutant gases that we have taken in chemistry are carbon monoxide and nitrogen monoxide. Okay. Question number 15. This is a very nice question. Remember, fickle, Brie. So it should be element plus ion will give us reaction. So we're talking Cl2 plus Ki. Cl2 is the element plus 2Ki, which is the ion, will have a spontaneous reaction. So this over here is spontaneous. So for this one, it is spontaneous. Then just remember, fickle, Brie. This one, I, can it displace Br? It definitely cannot. So this is non-spontaneous. And always remember, fickle, Brie. Br, can it replace Cl? It definitely cannot replace Cl. So this is a what? Non-spontaneous reaction. Moving on to question number 16. Here we have a hydrocarbon is 75% by carbon by mass. So it could be CXHY. We have 75% by mass. That means the other 25% is hydrogen, is equal to 100%. Let's say it is 100 grams. This is going to be 25 grams. This is going to be 75 grams. Now, to find the number of moles, we're going to divide by their molar mass. Okay, we get 6.25 moles plus 25 moles will give us 100 grams. All right, now to find the empirical formula, what we are going to do is we're going to divide by the smallest number, which is 6.25. So 6.25 divided by 6.25 is 1. And then 25 divided by 6.25 is 4. That means carbon 1, hydrogen 4. Usually we do not write the 1, so it becomes CH4. Okay? Moving on to the next equation, or the next question, number 17. Very simple. Okay, so a student wanted to find the maximum mass of aluminium oxide, Al2O3, produced when a sample of 0.8 mole of aluminium reacts with excess oxygen. This is the equation below. So, aluminium, the number of moles of aluminium, which is 4 moles, became what? Became 0.8 moles. So they need to find what? The mass of Al2O3 produced. So that means the 2 moles of Al2O3 is gonna become what? we do cross multiplication. So 2 times 0.8, which is 1.6, divided by 4 will give us an answer of 0.4 moles. So now to find the mass, we're going to take the 0.4 moles and multiply it by the molar mass of Al2O3, which is 2 times 27 plus 16 times 3. So 0.4 times 2 times 27 plus 16 times 3, we are going to get an answer of 40.8. So this is 40.8 grams. Moving on to the last question. Hydrogen gas H2 reacts with carbon monoxide to produce methanol, etc. They said when 0.5 tons of H2 gas reacts completely with CO gas, the amount of methanol produced was 3 tons. Now, they need us to find the theoretical yield. To find the theoretical yield, what we are going to do, first of all, is we are going to find the number of moles of hydrogen produced. So 0.5 tons, we will change it into grams. It's 0.5 times 10 to the power of 6 grams, okay? Divided by the molar mass of hydrogen, which is 2. We are going to get the number of moles to be 250,000. Okay, so 2 moles of H2 became 250,000 moles. So 1 mole of CH3OH is going to become what? 125,000. How did I get it? By doing cross multiplication. So I divided by 2, I got 125,000. Next thing we are going to do is we're going to take the number of moles and we are going to multiply it by the mass of CH3OH, which is 12 plus 3 plus 16 plus 1. Okay, so you are gonna get then 4 million. Now, we do not need it in grams, we need it in tons, so we're gonna divide it by 10 to the power of 6 to get 4 tons. So the theoretical yield is gonna be then 4 tons. Now, the percentage, to find the percentage yield, it's gonna be the actual yield, which is 3 tons, actual over theoretical times 100. So 3 over 4 times 100%, we are then gonna get 75%. So let's submit and hopefully we do not have any mistakes. Thank you guys for watching. I hope you enjoyed and have a wonderful day.